I'm Ambuj Varshney, and I'm a researcher at Uppsala University, and this is a project that we have been working on for a couple of years, and we are pretty excited with some of the results that we have.
Sorry, a little bit closer to the mic.
Okay, so we are pretty excited with some of the results that we have. So as the topic says, that can you actually achieve communication range as high as 1 kilometer while just consuming microwatts of power? And this is absolutely state of the art. So the idea is that we are already surrounded by many sensors. For example, we have on our wearable devices, we have Fitbits which keep track of your activity, or in your houses we have smart thermostats, or for example, in cities we have pollution sensors. But if you look at most of these sensors are battery operated right now. And in the next few years, replacing batteries on these sensors is going to be one of the major challenges that we are going to encounter. And especially considering the fact that most predictions state that we are going to have billions and probably trillions of sensors that are going to be deployed. So do we really want to actually have the logistical nightmare to replace batteries on all these sensors? In addition, these sensors also use toxic chemicals which are not really good for the environment. So we really want to have battery-free sensors. They also enable new applications, for example, like implantable devices or sensors which are embedded in the infrastructure. Because for these sensors, you cannot even have batteries because they have to be left inside the body for a long period of time. Then the key question is, how do you provide wireless connectivity to such sensors? And this is a question that is very unsolved right now, both from industry as well as academia. So the reason why it's actually unsolved and it's very difficult is that we are talking about energy consumption of microwatts and not even milliwatts, because most of the sensors that are used for Internet of Things, they operate on much lower energy budget as compared to your typical smartphones or activity trackers. And if we look at the source of power that is available for these devices, these are microwatts of power that are harvested from the ambient sources. While the communication, for example, the typical radio that is used, it consumes power of the order of milliwatts. For example, there has been a significant amount of momentum around LoRa, Sigfox, and narrowband IoT. And the peak power consumption of the radios that is used for is 200 or 300 milliwatts, which is several orders of magnitude higher than what is available from the ambient power sources. So how do we actually enable these sensors, which operate on harvested energy, microwatts of power, to be able to communicate wirelessly? And this is where actually leverage is a concept called backscatter communication, where we actually take advantage of the fact that on a typical radio, the generation of the carrier signal is the most expensive operation. Instead, if we task to a separate generates the carrier signal, we use ambient signals like television signals or wireless signals that are around, and at the sensor, you just reflect these signals. And if you reflect these signals, you can do it at microwatts of power consumption. You could enable sensors which communicate at microwatts of power to really long distances, because the energy expensive task is delegated to a fixed infrastructure. And this is what we have built over the last 1 year. So this is one of our sensor tag which communicates at microwatts of power. This is a receiver, and this is a carrier generator which generates a dedicated signal which this backscatters. And this is an experiment that we did near the river in Uppsala. So here we have a sensor that is placed at the bank. And here I'm about a kilometer away from the sensor, and we are able to communicate 1 kilometer away while just consuming 70 microwatts at the sensor. So 70 microwatts is something that can be powered by many ambient sources easily. So what we have right now are lab prototypes which outperform the state of the art from both industry as well academia. So we are in process of exploring filing US patents around some of this, but we are very much interested in new applications as well as products that could be enabled with what we have right now. So if there is any interest, these are my contact details, and I would be very happy to hear. Thank you.